Now we can step into the bracing topologies, each of which has its own pros and cons. However, we face issues with the durability and maintenance point of view. For instance, the way building is stuck on top of the colonnade. For instance, we have the middle point in the beam where diagonal intersects.
Thank you, Marco, and thanks to everyone for dialing in today. And obviously, a big thanks to WoodSolutions and Kylan for hosting and inviting us to present today. So my name is Jesse Hallen. As you saw, I'm joined by Marco Arcolini, and together we are the founders of TimberXP. And if you've ever wondered what the XP comes from, it is experience and expertise in structural timber engineering. So in terms of what we'll cover today, we'll start with a quick intro to our company. I'll then hand over to Marco, who is our principal engineer and bracing and connections guru. So he'll take us through some different mass timber bracing typologies. We'll look at connection details and some design considerations. We'll touch on structural analysis and specifically handling connection stiffness in a finite element model. And we'll close with some comments on holistic design, so considering aspects such as fire, manufacturing, and installation.
Thanks a lot, Jesse, and once again, thanks WoodSolutions for having us today. Before I start presenting, we appreciate that, and not everyone in the audience comes from a structural engineering background, so we keep our discussion high level and avoiding getting too technical. But let's get started. So bracing system typically, feature lateral force resisting system that provide structural stability into our buildings. And these kind of systems react to lateral forces such as wind and seismic. The placement and sizing of lateral force resisting system play a crucial role in ensuring stiffness, which is very important in order to prevent excessive lateral sway and twisting of your building, as well as providing the necessary strength for structural integrity. In addition to that, though, by properly designing bracing and connection in mass timber, we can enhance the design for manufacturing and assembly, which is the kind of DFMA approach that we know quite well. So making manufacturing and installation in that case as a very smooth and efficient process. But in order to achieve that point, it's crucial, in our opinion, to start since the beginning in thinking about the way you want not only design, but also physically manufacture and erect your building. In this case, bracing system. Now we can step into the bracing topologies, each of which has its own pros and cons. It's very important because understanding these differences, is key for you in order to select properly the bracing system for a specific given project, making sure you can deploy, the most efficient solution for your project. In here, for instance, we have a several bracing system applied to specific buildings. For instance, starting, from the left, there is the Bond in North Sydney, which uses a multi-story floor bracing system. Its primary advantage is good with, minimal facade impact, fewer elements, and connection number of connections that you have to deal with, typically ending up with cost efficiency. However, it faces some sort of, limitation in terms of stiffness and strength if compared with the other solution, and probably might pose some sort of challenges from a prefabrication point of view if it's needed. The middle one is the International House in Sydney, which is featured by a chevron bracing system, or as a well-known inverted V-shaped bracing, which offers, of course, high strength and stiffness in this case, but despite these benefits, it might raise some sort of concern in terms of complexity. So comparing to the previous one, given, the same building size, is essentially ending up with an additional number of elements you have to deal with that we need to, manufacture, we need to provide connection for, etc., etc. Moving to the right one, there is the Marine Teaching Center back in Canberra, which utilize an X-bracing system, which is known very well for its stiffness and strength. However, might rise some sort of, potential concerns, including aesthetic. Sometimes we have to deal with architectural, expectation or clients' need, and where actually they don't really want us to put bracing through glazing of facade. In addition to that, it might have some sort of issues, as I said before, in terms of manufacturing implication, which of course might impact the cost efficiency of your buildings. Another well-known system is the one using the Warren Truss, or a kind of combination of variation of Warren Truss, which features, for instance, the colonnade pathway in the International House, Sydney. And this system excels in aesthetic, glorifying the use of timber and providing this double high, colonnade pathway, which is unique, in my opinion, for this kind of building. However, it faced issues with the durability and maintenance point of view. For instance, the way building is stuck on top of the colonnade, and where, might pose some sort of challenge in terms of transition node for transferring properly the load. It might request additional design, specs and time consuming for dedicated, transition steel node. That, of course, is going to impact cost efficiency of your building, of your project. Well, finally, we have an example. This is a next bracing system. The particularity of this one is the location where the bracing intersect, which requires specific attention and solution in order to make sure we can deal properly with this kind of detail. And the advantage by this system is about, the great level of stiffness you can achieve, and even the level of prefabrication and standardization that actually you can achieve. Okay, so in terms of connection design, we should probably first ask us about what kind of role do connection play in timber construction. Well, in my personal opinion, connection are where the truly, magic happens. They do much more than just holding pieces, element together, but it's the way actually we can transform individual pieces into a cohesive functional structure. So we can definitely say that, connection in bracing systems serve two main purposes. They assemble element into the design and shape we want to achieve, as well as it does provide the necessary stiffness and strength we need. Here is about the way we can discuss the importance by specific location and details in mass timber bracing. For instance, we have the middle point in the beam where diagonal intersects, as well as we have the this location in where essentially, diagonals approach the corner defined by columns and beams. And as I said, these locations are crucial, in terms of number of elements to connect, and also in terms of fixing we need to deal with, the way we need to process timber element in the right way, and everything are connecting together properly. Another one, of course, very crucial in our opinion, is at the ground level, where the intersection in between multiple material is going to play an important role. So in here we do have perhaps steel, timber, and concrete, connecting, interfacing together. So this is a kind of situation in where a very holistic and synergy approach, talking with supplier plus builders and installer, is going to play an important aspect of your design process. Also, by looking at the top right image, it records me the importance of properly engaging the bracing system. In fact, in all cases, it's paramount to transfer diaphragm forces from the floor slab back to the bracing in a proper way. And for instance, depending on specific situations, we might need to design specific connection for slab to beam, slab to slab, and slab to bracing system. And in that case, sometimes additional steel elements such as strip, chords, and collectors might be necessary in order to enhance, the connection intents as well as the transition of loads.